Hello, good morning. We've got a couple more on their way. In the meantime, Annette, make sure to make a copy of the slides that are on that first post in Classroom. And then there's going to be a Google Drive here I'm going to post as well. We'll wait probably 7 more minutes. I think people are a little slow today, I guess. You can't hear me? Testing, testing. Um, Emma, are you able to hear my voice? Yes? Okay. Edna, maybe try leaving and then re-entering, or maybe changing something with the mic setting. For those of you guys that just joined, you can go ahead and make a copy of the Google Slides that's on the first post of Classroom. So you'll open that link and then click File, Make a Copy, Entire Presentation, and that will get you set up there. One sec. All right. Okay, and then this file that I'm going to put in the chat, I want you guys to go ahead and make a copy of that one as well. That's going to be the Google Draw file. And that'll just make it a little bit easier to follow along and do one of the little activities we're doing today. Okay. Awesome. Good job, Emmett. So if you copy and paste this link right here, That'll take you to the file and you make a copy of that as well. And we'll just wait, maybe, we got a shorter lesson today. We'll make about 1 more minute, see if anybody else hops in, and we'll get started. All right. All right, we're going to go ahead and get started. We're going to start on our slides page. It should look like this. And I'll go ahead and show you this too. Just making sure we're on the same page. When you guys open the slides page, you want to make sure you click File, down, make a copy, entire presentation, and open it from there. Okay, so that's how you guys can make you can get the slideshow and you can edit it. That way you're not editing all the same page together. So just checking on that. All right, so let's get started. Today, we are talking about systems of equations. Systems of equations are actually super cool. You guys are going to be touching on that even more next year in 9th grade. But part of it you talk about here in 8th grade. And systems of equations, not only are they super cool, they're just the way they work. If you guys know how to graph lines like you've been doing, as long as you know some of the basics of coordinate planes, then you guys will have no trouble with it, and it's kind of fun. So let's go to, and here's a couple pictures of them. Let's go to the definition of systems of equations. So the definition of a system of equations is a set of equations with the same variables. So what that means is, just like before, how we graphed a linear equation, if you have more than one linear equation, excuse me, or even, I guess, you know, even non-linear equations, but usually it's going to be just linear equations. If you have 2 or more lines that have the same variables, it's a system of equations. In this case, the same variables that we're talking about is x and y. Okay, anytime we're looking at a coordinate plane, right, there's only 2 dimensions. There's our y-axis, which goes up and down, and our x-axis that goes left and right. So here is an example. This one says 2x minus y equals 2. This one says 2x plus y equals 6. Those are our 2 equations. They both have an x and a y in it, and they both have a couple other numbers. Okay, so some examples of what this looks like. Algebraically, it could look anything like these 3 or even more. Let me make sure I got this up in case people join in. Okay, so it could be anything like this. Usually, this one that I'm drawing my mouse around, let me see if I can. Oh, sorry about that. Okay, usually like this guy is how you'll see it. At least that's what I've seen the most. Is you'll have this kind of like little bracket here that kind of looks like a staple. And you have your 2 equations or 3 equations, you know, however many equations it has. Since we're starting out nice and easy, just doing 2 equations, I think that's all you'll see this year. So we've got y equals 5x plus 15, y equals negative 5x plus 5. Those are 2 equations, and together they're in one system of equations. These are obviously in slope-intercept form, which, if you remember, is y equals mx plus b. right? Quick spot check. I know we just talked about this the other day, but it's been a half a week. Go ahead in the chat. I want you guys to tell me, what does M represent and what does B represent in slope-intercept form? This is a slope-intercept form of a linear equation. What would M represent and what would B represent? Go ahead and put that in the chat. Good, and you can message privately or together. I need to pause this just for a sec, guys. Yeah, so what does M represent? What does B represent? And Zeta, what do you guys think? And Zeta, you guys there? No wrong answer. What do you guys think? All right. Okay. That is A-okay. All right, so if it says y equals mx plus b, this is our, it's called slope-intercept form of a linear equation, and m represents our slope. So, and again, the nice thing about math, as opposed to maybe a couple other subjects or science and things like that, the name is always, for anything really, is usually exactly what it is. So this is called slope-intercept form because it gives you the slope and the y-intercept and nothing else really. There's another form called standard form, which goes kind of like ABC. And then there's like point slope form, which would give you a point and a slope. So the names kind of tell you what they are. So slope-intercept form gives us our slope. Whatever comes in front of our x is always our slope. And whatever's on the tail end is our y-intercept. All right. So just remembering that as we move on. Okay, and then over here we've got another system of equations. It doesn't have the bracket, but they're next to each other, so we know that this is some sort of system. They're both in slope-intercept form. This one, y equals 2, x equals 7. Those look kind of weird, right? You know, one just says x equals 7, one just says y equals 2. But they are both still equations and both still linear equations. They just, on this one, the x value is 0, and on this one, the y value is 0. Okay, so if I were to write these as linear, if I wanted to write it as close to slope-intercept form as possible, I could say y equals, 0x plus 2. That's really what this is. Y equals 0x plus 2. And if you want to be writing this on your slides as well, you could. Y equals 0x plus 2. And so this one then would be, let's see, if I subtract the 7 over, it could be y, which is a 0, equals x minus 7. Oops. Fix that. Okay, so if, fix this, 0y. Okay, so both of these are, hopefully you can see now, both these are linear equations. You just have, one has a 0 value for x and one has a y value for x. That way when you have 0, oh, I didn't do that right, sorry. Let me fix this real quick. The 0 shouldn't go in front. That's the mistake I'm talking about. The 0 is what x is, or 0 is what y is, right? So on this one, it should just say 0 because the value of y is 0. And on this one, the value of x is 0. And then what that means is no matter what the slope is, like let's say slope was 3, then that 0 times 3 is just going to be 0. Okay, so that's why this one just becomes y equals 2 and x equals 7. Okay, and y equals 2 would be, just so you know, would be like this, right? It would be at 2 above all the way across. That's the line of y equals 2. And x equals 7 would be a straight up and down line where x is 7. Okay, something like that. All right. Graphically, like we kind of already said this, they could look like this. They could look like this. They could look like this. A quick point to notice here, guys, is I'm going to choose a different color. Here's two lines intersecting, right? We got two linear equations that are graphed. They meet right here, don't they? Okay. What about this one? There's two lines that are not touching each other, right? So there's no touching there. And then here it's the same line. I don't know if you guys can see that, but it gives you two different equations. Y equals 2x plus 1. And then this one that says negative 4x plus 2y equals 2. Even though they look and sound different. This one's in a non-reduced, let's see, standard form. And this one's in slope-intercept form. So it's actually the same line. There's a red line here and a blue line here at the same time. So a system of equations, if it's two separate lines, they can cross each other like that, like an intersection. They can go parallel, or they could be the same line. Okay. All right. Moving forward, let me pause real quick. This is pretty crucial. Let me ask any questions so far with just like what a system of equations is. Good, Emmett. Okay, so good, guys. Yeah, if you have any comments or questions, feel free to put it in the chat. That way we can answer them, okay? Especially with a smaller group like we have today. We can pretty much answer any question you want on the spot. So, all right, system of equations, two or more lines at the same time. So now looking at this, so those were examples of system equations. What is not a system of equations then, right? Well, that could be anything that has one line, right? Or things that don't have the same variables. So let's look here. This one right here is not a system of equation because where's the other equation, right? There's only one equation here. And that one's in slope-intercept form. This one is in some other form. It's called standard form, but you'll learn more about that next year. So that one's in standard form, but there is, again, no other equation. So it's not a system of equations, right? Not a system of equation. And then this one, oh wait, this one has two equations. But this one says y equals 2x. Okay, that's fine. This one says a equals 9b plus 1. Could also be fine, but they don't both have the same variables, right? They'd have to be, this one would have to have a y and x in it, and this would have to be a y and x. Or AB and AB. But since they don't have a common link, no, they're not a system of equations. Okay, all right, graphically, this one. Is this one a system of equation? Nope, right? It's just one line. We need more than one line. This one, it's got a negative slope. Again, still one line, so no. Not. This one, it's a parabola, y equals x squared. But again, that's not two lines, that's just one equation. So, nope, no good. All right. So, we just went over first between what is a system of equation and what is not a system of equation, right? Systems of equations, not systems of equations. So what I want you guys to do now is I'm going to share this again in the chat because I don't think it went to everyone. You can follow along with either the slides or the draw. I just shared the draw in the chat, guys. So if you copy and paste that link and click make a copy, then you'll have I'll show you what that looks like. You'll have a couple of these slides that you can draw on. So let me show you what that looks like. So if I copied and pasted that link, it would take me here. Okay, and so I see I've got a couple slides. I can zoom in as I need to. But before I do any of that, zooming in and writing on it, I need to click File, Make a Copy, and I'm just going to say Elander 414 System Equations. Okay. And it just makes it your own. You have your own copy of it now. Like that. There we go. It's looking good. And then now I can move things around. I can draw on stuff. So like, for example, we're going to be moving these little tiles. So you can say, I think this one's a system equation, and this one is not. So you can move them however you need to. Okay, that's what I want you guys to be doing right now. All right. So put these in which boxes you think they go in, and then I'll show you mine. I'll get off your screen here so you can do that. Make sure to make a copy of that link I just put in the chat. Okay, we'll take about two minutes or so trying to separate those out. Nice. Good job. We will say about another minute, and then we'll go over it. Okey-doke. If you got yours done, will you let me know in the chat, or you can do the little symbol if you know how to do that. It's the little, where does it say? Oh, reactions. Okay, you guys think you got it? Let's check it out. Share screen. All right. So it should look something along the lines of this, right? Hopefully if you didn't get it, you got close. This one's got two different equations. Again, this one, the y is a 0 and the x is a 0 on this. We've got our, excuse me, we've got two equations here, y equals x plus 5. Again, two equations on this one. This one, it's got an x and a y, but it's only one equation. Same with this one, same with this one and this one. They're all only one equation, so they're not a system of equations. Okay, they might be a linear equation, but they're not a system of. All right, so now let's look at this next slide here, and it should be this, just making sure. Oh, not yet. Okay, So back on the slide sheet, leave that Google Draw open. We'll come back to that in just a moment. So solution to a system of equations. So that we just talked about what is a system of equation, what is not, right? We said it's got to have two equations, at least two equations, and they have to have the same variables. All right, so this says the solution is the point or coordinate pair that makes all of the equations in the system true. Okay, I'll say that one more time. I want you guys to either circle this or kind of read it to yourself. The solution is the point that makes all of the equations in the system true. Okay, that's key. So the solution is the point or coordinate pair that makes all the equations in the system true statements. So looking at this guy right here, we've got a system of equations, right? Y equals 3x plus 5, y equals 1 minus x. And we're going to see if this solution here is actually the solution, okay? It could be a lie, it could not be. Right? So we're going to see, is this a solution? I'm going to put a question mark. Is this the solution? -1, 2. Let's see. So if every coordinate pair is made up of an x and a y point, right, guys? If you remember that, every coordinate pair is made up of an x and a y. I guess I'm not using the right colors. Let me fix that. How about we do the colors that are there? Purple and blue. So purple and blue. Okay, so let's substitute these values in. This is how you do it, guys. To find the solution or to check and see if it is a solution, you plug your values in or substitute your values in to your equations. So look here. We've got y equals 3x plus 5. That's our first equation. Okay, the x that we're looking at, right? This is an x and this is a y because it's a coordinate pair. X is -1, so I'm going to substitute that in right over here. You guys see that? The y I'm going to substitute over here. Okay, and I'm going to actually do the same thing to my other equation as well. I'm going to put my x right over here. And my y in for my y. I'll pause there for a sec. I know the arrows look all crazy, but does that make sense? Okay, we're taking our x value of that point that we were given and the y value of the point we're given and plugging them into our equations. Now let's see what happens. All right, we've got -1 times 3. You guys see that? If this is 3x, it's 3 times x. 3 times -1 is -3. The 2 is just over there by itself. We didn't touch it. So now we have 2 equals -3 plus 5, right? Well, if we add -3 and 5 together, -3 and 5 together, we're going to get +2, right? So we've got a +2, and this 2 is still over there. So 2 equals 2. Is that a true statement? Thumbs up or thumbs down? Is 2 equal to 2? Yeah, of course, right? 2 is itself. Good. So then we check this one. We plugged in our -1 for x, our 2 for y. 1 minus -1. Okay, again, I can do 1 minus -1, but to me as Mr. E, I find that confusing. So we go back to what you guys learned in 7th grade. You can change this to adding a positive, right? Yep. You can, if it's minus a negative, you can change it to adding a positive. Change the operation, change the sign. So now it's just 1 plus 1. Oh, that's 2. And this was 2. So is 2 equal to 2? Yeah, we already said that. Ding, we got it. Champions. So this means that we've got a solution, okay? So if we said, what is the solution to this system of equations? Basically, what coordinate pair works for both of these equations? Well, it's gonna be -1, 2, okay? All right. We pause for questions there. I know I'm doing a lot of talking. That's why I'm asking for questions. If you guys are confused, you need help. All right. Then if not, let's keep going. All right. Determine if a given point is a solution to the system. And I kind of jumped the gun there, I guess. And this shows us how the solution works. But this is going to show us actually doing the process. Okay. And then after we do this one together, I'm going to have you guys do a couple on your own. Okay. So be ready. Determine if a given point is a solution to the system. We've got 2, 5. Okay, that's a coordinate pair, right? In the near future, in 9th grade, I think, you guys will have to be able to solve these systems of equations 3 different ways. Okay, this year you'll only learn one way. Okay, you'll learn how to solve it by graphing. But the only other thing that you guys will need to know how to do is if you are given a point, so instead of having to find the point, if you're given the point, you have to be able to test whether it is a solution to the system or not. All right, so to determine if a coordinate is a solution to the system, we substitute the x and y coordinates into both equations. If both equations are true statements, you've found the solution. Okay, so I'm actually going to have you guys start me out here. What is going to go in this red box and this blue box? What is x and y on this? Easy question. I just want to make sure you guys are engaged. You guys tell me what's going to go in all my red boxes and all my blue boxes. Go ahead and answer in the chat. What do you guys think? Don't be afraid. What is going to go in my X box, my red box there, and my blue box? If we are given, so they give us the coordinate pair 2, 5, right? So they say 2, 5, is that the solution? And we're going to check it, but what do we put in this X box here? What is our X? You guys got it? What do you think? What goes in our X box here? What is our X up here? Good. Awesome. Anyone else? Agree or disagree? That meant you can give a thumbs up or a thumbs down if you agree or disagree. Agree. Okay. All right, good. So this is going to be 2. And so then what is our y going to be? 5. Excellent. So if this is 2, because it's our x, this is going to be our 5. Okay, coming from this guy right here, right? They said, is this the solution? Question mark. And we're saying, I don't know, we're going to check. So we take the 2, we take the 5, we plug them into our equations. So let's check it out here. This is y equals 2x plus 1. You guys see that? I just drew colored boxes to make it a little easier to see. But that's our equation, y equals 2x plus 1. And this one is the other equation, y equals 3x minus 1. You see that? So I'm going to take my y's plug them in for my y's in both equations. I'm going to take my x, plug it in for the x in both of my equations. Okay, and so now we say 2 times 2, what is that going to be? That's quattro, 4, right? Plus 1 is then 5. Good. So then now this says 5 equals 5. Is that a true statement? Yes, it is, right? 5 equals 5. Ding. That's a true statement. That makes sense. 3 times 2. Now this is the other equation. 3 times 2 is 6. Good. Minus 1 is going to be what? 5, right? So we again have 5 equals 5. Again, that's a true statement. Same numbers as the last one, ironically enough. So this is now true, true. So this means this is the solution. So I can erase my little question mark here and say, yes, it is the solution. Da-da-da. So we got it. All right. So again, we're not solving. We're not having to find this point yet, guys. Okay. That's the good news. You don't have to find this point yet. All you need to be able to learn today is what is a system as opposed to what is not a system of equations, and be able to test a point. If I give you a point and say, is this the solution or a solution, you should be able to say yes or no. Okay, I'm talking too much. So I'm going to go ahead and let you guys take the first one. We got 3 of these. I want you guys to try this one and see, is the point a solution to the system? Okay, so you take this coordinate point or coordinate pair, and I want you guys to fill in your boxes, check and see, is this a solution to this system? Once again, you're going to use that draw file that you guys just made a copy of a little bit ago. You can see on my screen here. If it's a little small, you can zoom in if you need to. Okay, and then if you're on this screen, you can draw on it. There is a draw button somewhere. I'm a little new to this one, but I'm sure you guys are pretty sharp. I'm sure you can draw lines. And mainly what you need to be able to do is use the little cursor, right, to move stuff around. So if you can move stuff around, you'll be able to, like for example, you'll be able to take this circle and say either yes or no. Oops. Hopefully, unless you're struggling like me. Maybe I can just do it like this. So you could say no, or you could say yes. Okay, so you can use that or Google Slides, whichever one you find easier to fill in, and check and see what you guys get. I'll hop off the screen. So you're fully solving that practice problem. guys are doing great. Say about 1 more minute, because I know you guys are filling everything in, checking it, seeing if it's your solution. And then in a moment, I'll ask you what you guys got. Okay, about 30 more seconds. Alrighty, so go ahead, put in the chat what you guys got. You can just put a yes or no, and let me know what you guys got. Okay, good. I got a couple answers. Waiting on one more. Alrighty. If you're still finishing up there, that's okay. But let's go ahead and check and go over it. So, and that, yeah, that should be the correct equation. All right, so let's go ahead and check. Here is our point that we're given, negative 1 comma negative 2, right? Every coordinate pair is made up of an x and a y coordinate, right? So my x is going to be the first one, x comma y. So x is 1 and y is negative 2. It's not a very good looking one, but we're going to go with it. All right, negative 2 is here. So now we have our x and our y, and now we just plug them in, or I should say substitute them in to our two equations. So let's take our 1. Anytime we see an x, like right here and here, I'm going to replace them with 1s. So that would be right here and right here. Man, I am not doing good with 1s today. All right. There we go. Maybe that's a little bit better. All right, 1 and 1, and then negative 2 for the y's. Okay, so now I've substituted those values in. Now I see if it works. Let's see if it's a true statement. 3 times 1 is 3. Minus 5 is negative 2. So we've got a negative 2 here. And a negative 2, of course, on this side. Is negative 2 equal to itself? Of course. So we know that one works. Negative 6 times 1, that's going to be negative 6, right? Negative 6 plus 4, that would get us to negative 2. Good. So we've got negative 2, and of course, again, negative 2 over here still. So yeah, they're going to be equal to each other, right? So this worked, this worked. So is it a solution for the system? Yes, it is. I can't move that circle on this one. So I'm just going to circle this. Yes. All right. So all we're doing is substituting a coordinate pair in and seeing if it gets a true statement, like 2 equals 2, 5 equals 5, things like that. Just make sure when you plug them in that you solve carefully, do order of operations, okay? This was just 2 steps, 3 times 1 and then minus 5. Just make sure you're careful. All right. Let's do, I'm gonna have you guys do the next one as well, and then we'll do the last one together. Okay, so once again, this one, I don't think there's a draw for, so you can do it on your slides. Or again, you can do any of this on a piece of paper, right? Like, honestly, with a piece of paper, it might be easier. You could just write these two and then plug in your values. But it's up to you. So take this point here. This is your coordinate pair. And I want you guys to plug in your values and see if this is a solution. Alrighty. So I'm gonna hold myself accountable. I'm gonna say 2 minutes on this to get your answer. Ready, set, go. Give me 1 sec, I'll be right back. Oh, on a piece of paper. Okay. Yeah, just in case, I'll put this back on the screen. Still have about 40 seconds. So go ahead and make sure you're plugging in your values. See if it's true. See if it's a solution to the system or it's not a solution to the system. All right. All right, give you a couple extra seconds. So what did you guys end up finding out? Let's see. Never shows me the chat. Cursed. All right. So you can put your answer in the box. I got one that says not a solution. What do you guys think? Maybe it is, maybe it isn't. What do you think? Okay. Alrighty, so let's check. Good, thank you guys for responding. All right. Okay, so if I'm checking this, I write down, this is just kind of for me to keep track. I say, okay, my x value is a -2, and my y value is a 12. Put those in, and so now I say, okay, I know what my x is, I know what my y is. So I'm going to plug them into my equations. So I'm going to plug in, or substitute, I should say, -2 in for x, right here, right? I'm basically plugging in there, and plugging in for this x here, -2. Now I plug in my y value, my 12, in here, and in here. All right, now let's see what happens. We got to be careful how we solve to make sure we don't make any mistakes. But we've got 8 times -2 is -16, right? See if I can draw better. Oh, no, can't draw better. All right, -16 plus 4, that's going to take us to -12, right? So now we have 12 equal to -12. Okay, and that's not looking good, right? So they are both 12s, right? But this one's a -12. It's a different number. So instead of a check mark, we've got a little x here. All right, let's see. Let's check this one. A negative, so, and technically, I should say this. What's the point, and this will get you thinking here real quick. What do you think, why am I going to check this other one? Why can't I just say, hey, that one didn't work, so it's not a system of equation? What do you think? Could I do that? Could I just stop now? Since I found one that doesn't work? What do you think? Bear with me, guys. You guys got it. Okay. For being a little shy, it's okay. I could stop here. That's the short end of it. As soon as you find one of them that doesn't work, you can say, doesn't work. It has to work for all the equations, right? If we had 3 equations, it would have, this point would have to work for all 3 of the equations. If it doesn't work for any of them, then it is not a system of equations. So I could stop here. But what if I made a mistake, okay? If I didn't do my math right, if I messed up somewhere over there, then maybe this was true and I messed up. So I'm going to go ahead and be safe and do the other one. Okay, that's why. So we can stop here. It's not a solution, or sorry, it's not a system of equations that is solved with -2, 12. But in case I messed up, I'm going to check. All right, negative of a negative. That's like saying the opposite of an opposite, right? So if I say negative of -2, that's going to be +2, right? Yep. Or you could think of it as -1 times -2. Again, still gets you +2. Good. Good, Emmett. So now we have 2 minus 10 equals 12, right? So then 2 minus 10 is going to be -8, right? So -8, and then this is 12. So does -8 equal 12? No, it doesn't, right? Nice. So nope, it didn't work for that one either. So I can say, no, it's not a solution. Now, could there be a solution to these 2 equations, this system? Yeah, sure, right? It's just not this point. It's not -2, 12. That's all we know for now. Okay, all right. Last one, let's do it together, and then you guys will be done, okay, for class. So I've got 1, 3, x, y. Okay, I've got 1 is my x, 3 is my y. I'm going to plug in or substitute in my 3 for all my y's. Okay, and 1 for my x's. So if I do that, it'll look like this. And 3 for y, so that goes there and there. All right, so this now says -1, or -1 times 1, which again is -1. Change colors. All right, -1 plus 4 is going to be what? What do you guys think? Okay, Emmett's saying 3. What do you ladies think? 3, do you agree or disagree? Agree? Okay, what do you think, Zeta? Alrighty, I'm assuming you agree. So let's check here. We've got 3 and -1 plus 4. That's basically 4 take away 1 is 3. Okay, so that worked. Ding, that's good. It has to work for both of them, right? Otherwise, it's not a solution to the system. 3 times 1 is 3. Okay, that's an easy one. 3 equals 3. Ding. Got that one right. All right, so this is a solution, yes. 1, 3 works for both of these equations. So it's the solution to the system of equations. All righty, so your assignment. We have just one set of IXL that I want you guys to try. You can follow the link in the slides, or it is AA1 in IXL. I want you guys to try to get to 80 SMART score. Yeah. 80 SMART score for that. Okay, I'm gonna put a little asterisk here. Again, remember, anytime you see an asterisk, it's just a reminder that it is for a grade. Okay. I don't see you guys having too much trouble in it. You just plug in your values just like we did. Same exact thing that we're doing to see if it is a solution. Okay, so you've got this, and then I've got a short little quizzes. It's 5 questions to see if you guys are doing okay. Okay. Yep. We're done. So make sure you guys don't forget to do that. You can do, my suggestion would be to try to do maybe the IXL today. And if you have time, the quizzes today. The quizzes is, like I said, really short. It's 5 questions. So you can do them both today. You can do the IXL today, the quizzes tomorrow, however you want to split it. But make sure that you guys do both of these. Alrighty, and this will be on the stream, like usual. All right, stream. Yep. So you guys are good to go. So I see you, Emmett. Thank you guys so much for being here, participating. Hope you guys have a great day.